The gRPC team has just submitted a proposal to support HTTP 3 underneath the gRPC protocol. This is exciting. Let's discuss what does that mean for all of you gRPC users. Let's just jump into it. Welcome to the Backend Engineering Show with your host Hussein Nasser. And gRPC, guys, it is described as this ultimate universal RPC, or remote procedural call protocol, or really a way for a communication between two peers. So many protocols have came before gRPC. gRPC kinda, people might disagree with that, but kind of put the nail on the coffin to communication between two parties, two computers, a standardized way of communication, right? And I talked about why gRPC was kind of the winner, and why you would pick a gRPC over any other protocols. It's really mainly because of the use of the protocol buffers, which makes the communication kind of standardized, and the support of languages, right? You see, the most critical and really painful thing for a developer to maintain is a client library to communicate between two parties, right? That was like the ugliest thing, because if you picked a protocol X to communicate in X, you need to understand how to talk X, right? Whether X is TCP, HTTP, HTTP2, UDP, SOAP, REST, doesn't matter, right? You need to understand how to talk that language. And in order to understand that, you need this language translator, right? That talks in that protocol. So thus, you can bake this into your application, or create an application library, client library, that knows how to talk gRPC, or how to talk TCP, or how to talk HTTP or HTTP or whatever. And people use just to import these libraries and then call in into these libraries, right? That was painful, because anytime you want to upgrade, you need to find a library that is supported, right? That is maintained, that people upgrade with it, or you need to fix it yourself, which people don't have time for. I'm already busy maintaining my own application. Why do I need to start managing the HTTP library for .NET 3.0, right? Or whatever, right? So you find yourself always upgrading and finding a compatible library, and that was a challenge. Sometimes things break when you want to move. So it was a sticky thing. gRPC changed that, and I talked about it in my gRPC video. Go watch that video if you want. It's a lengthy video detailing all of that stuff with examples and stuff like that. So gRPC, once you pick gRPC, you're set, right? You will build your proto file. This is your schema that you need to talk through, and then you would basically pick the language, and it will literally stub out what the functions that you need to call in, and it will take care of how to talk in gRPC language, right? And then you get all the feature for free, like the bidirectional streaming, the unidirectional streaming, and then multiplexing, all this beautiful stuff, right? So we know that why people pick gRPC. I know a lot of people, especially Spotify, for example, they wrote their own protocol that before gRPC days, right? That is arguably even better than gRPC. And it was working perfectly for them. There was no problems with their protocol. I think it's called Hermes, right? And they ditched it. Why? Because no one else know what Hermes was. It's hard to learn or teach people about Hermes because it's not a public thing. I don't believe it's open source. Maybe it was, but it's not popular. If something is not popular, Nobody knows about it, so you need to train people about this new thing that you only know about. That's why they ditched it for gRPC, right? It tells you why popularity is an important thing, right? In programming and software engineering, sometimes you adopt something just because it's popular and because it's widely used, because it's cheaper. So gRPC is built on top of HTTP2. Why is that? Because it had the idea of streams, like this individual streams in a given connection. So you'd open a connection, and then in a given connection you can pick a stream, and you can stream content on that stream, while you can send a request response on another stream, while you can on the third stream you can do a bidirectional communication, while the fourth one you can do a server sent event, kind of a situation where the server only send you logs, right? You can do all of that stuff in HTTP2, right? So gRPC team built all of this low-level control on top of HTTP2, right? I talked about HTTP2, guys, if you want to learn more about them. That is as opposed of opening a TCP connection, opening a connection for every single thing that you want to do, right? Which is expensive. We know how expensive opening TCP connections are. gRPC was built on top of HTTP2. It's working perfectly. People love it. You don't even need to understand that HTTP2 is under the hood, because that's another property of gRPC. It's hiding the implementation for you. It's just hiding the stuff for you. So you don't really care if it's using HTTP2 or not. You ask gRPC, hey, I want a channel that is a bidirectional to the server, and we'll open one. And if you want another channel, it will open another. I don't know what it's called. I forgot. It's been a long time since I built that gRPC content. But you basically built multiple channels or streams on top of one connection, and that's the multiplexing concept is what's powerful here. It's the flexibility. You almost have everything you need in one protocol, and who can say no to that? So gRPC is using HTTP2 for this reason. For the longest time, I've been following an issue, right, in GitHub. Someone asking, it's like, okay, guys, when are you going to support HTTP3? And you might say, Hussein, who cares? HTTP2 is working. Why would you need to support HTTP2? And why do we need to support HTTP3? And that is the question gRPC team asking themselves. Is it really, do we really need to move gRPC? And they were really, seems like they didn't comment at all about this. They let the community talk about themselves, like, oh, whether we need gRPC or not. On top of HTTP3, what is the value here? Are people really having problem with HTTP2 and stuff like that? And I'm gonna summarize. This is a show anyway, right? This is a lengthy show, so I talk about one topic in a length manner. So that's why this is not a 1 minute or 2 minute show, right? So I always like to do these shows because I have the freedom to talk about a topic as lengthy and go to tangents as long as they are relevant, as far as I want, and as long as I want, and that flexibility, I really enjoy this. All right, so let's talk about what is wrong with HTTP2 to begin with. All right, I kind of made a video about HTTP2 detailing this, but it doesn't hurt to repeat, right? We have an item in Arabic. It's called التكرار يعلم الشطار. But it means that if you repeat something, it sticks. That's what it means in a nutshell. But HTTP2, guys, is built in itself on top of the TCP protocol, just like HTTP1. And the reason it was built is because of the idea that a client is making a flux of requests to the same server. One client's making a lot of requests to the same server, and these requests are stateless, and usually they are not dependent on each other. So it is fine to send them in parallel, and it is fine to the server to execute one after another, or execute them not in order particularly. So, and this is the nature of the web. If you notice, you visit National Geographic, you're flooded by a lot of resources that you have to download. What do? You have to turn around and request all this stuff. It doesn't matter if the image comes before that. Well, some front-end engineer will say, no, Hussein, it does. I really want my layout to be perfect, and I don't want like the image to come before the CSS, so that the page starts shuffling, changing on you. Some people don't like that, but it doesn't really matter. You can control this in the client side, I believe. But it doesn't matter. When you download these things, once you have everything, you want to receive these resources as fast as possible so you can make these decisions. You can't do that with TCP. Why? Because, well, TCP is a single channel, right? Single path. And if you send your first request, right, in this TCP, you can follow it with multiple requests. And a request here is really, if you think about it, it's a bunch of strings, HTTP strings, that will be packaged into TCP segments. So one request will equal, I don't know, 10 TCP segments, right? So they will be just one after the other, right? And the server will receive them, and the server has to like parse until it, oh, this is a one request, stop. Oh, this is a second request, stop. Oh, there is one TCP segment lost, let me wait. It has to do this work, and they received an order. But the problem is, the server is, for long history reason that I don't want to go about, has to also execute them in order. Right? It cannot just it receives all the three requests, but it cannot say, oh, request 1, I receive request 1, 2, 3 in order. I'm gonna execute request 3 and 2 and 1, right? It might execute the 3 of them at the same time, asynchronously, right, on the back end, but it has to respond in the same order that it receives them. This is the way it has to, because otherwise proxies and middle boxes in the middle will say, okay, you respond with request 2, but how do I know that response 2 is actually belong to request 2? There is no knowledge, no links between those request and response, right, in the HTTP standard. So you would end up with an D order effectively, right? And that's a problem. So you end up with this head of line blocking. So request 1 will be sent 2 and 3, and the server will have to execute response 1, response 2, and response 3, and execute them and send them in this order exactly. Even if response 3 takes less time, even if response 3 finishes first, it has to wait for response 1 and 2 to finish. So this is called head of line blocking, and this is a problem in HTTP 1, which, right, HTTP 2 solved, quote unquote solved, and says, really, we don't really care, because request 3 has nothing to do with request 1. So I want the ability to send request 3's response even if request 1 didn't finish. I don't want this blocking thing. I don't want to be blocked. So HTTP 2 had the idea of actually structuring requests in an actual header forms, like it down the wire header form. So the HTTP 2 is actually a breaking change when you look at the content, right? From the client's perspective, nothing changed. It's a completely non-breakable change. But when you look at the TCP, what is the content sent is a completely different thing. So now we start tagging with stream ID. So if I send a request 1, I'm gonna tag it with a stream ID, right? Or think of it as like a channel. I like the name channel better than that. So request 1 will be tagged with channel 1, request 2 will be tagged with channel 2, and request 3 will be tagged with channel 3 or stream 3. So now if these 3 segments, or if these 3 requests are arriving, they are arrived and they are tagged properly. So if the server receives request 3 and 2 and 1 and finished request 3 first, it can just respond because it will be tagged properly with stream 3 or channel 3. right? So the client will know, oh yeah, I sent that, but it's actually response 3. Okay, I know. The client knows this. And the beauty of this, all of these are in a single TCP connection. We don't have to open multiple TCP connections to achieve this parallelism, if you will, right? That's what HTTP 1 did, because it didn't have a choice. It used to open 6 TCP connections. That's the default in browsers. They opened 6 TCP connections in HTTP 1.1 and then flood every one. So that's how they uniquely tag requests, right? One request per connection at a given time, right? So yeah, HTTP 2 was awesome. People loved it. All right, the streaming, and obviously they went through a lot of repetition, a lot of revisions until it was kind of polished and finalized. So it was good. What's wrong with it? Ironically, the head of line blocking, while was solved at the logical level from a request response perspective, I can still, response number 3 can still be sent even if response number 1 was not completed. All of this is sent on a single TCP connection. So that means if request number 1, request number 2, request number 3 are being sent, even tagged with these streams, at the end of the day, it is nothing but TCP segments at layer 4. When you look at the lens and layer 4, it's just a bunch of TCP segments. Well, might as well encrypted, sure, but they are just a segments. They are sequenced. They have a sequence number, and they better that sequence number, they better reach an order. Why? Hussein, you just said no, order doesn't matter. Well, I said order doesn't matter on the application side, but I didn't say anything about the TCP. TCP still say, hey, you're sending packets 1 through, let's say 1 through 9. Let's say every request has 3 segments for simplicity, right? So packet 1, 2, 3 belong to request number 1. Packet 4, 5, 6 belong to request number 2. Packet, 4, 5, 6. Packet 7, 8, 9 belong to request number 3, right? So they are stringed 1 to 9. These are the serial representation of the sequences in the TCP stack. All right, let's take this scenario. Let's say the client sends all the packets, right, from 1 to 9, right? And the server receives all the segments, right, 1 to 9, but number 4 was missing. It didn't arrive. Well, it went to a path and it took too long. What will the server do? The server says, well, segment number 4 is missing, but 1, 2, 3 is there. So that's request number 1. And request number 3 is actually 7, 8, 9. So that also, I got that. Will the server do that? No. Remember, the server is just TCP at the end of the day. These segments to the server, this is an incomplete packets. This is an incomplete transmission. The tool says, wait a second, the whole thing is blocked. The whole thing is blocked. I'm not going to send anything to the application being the actual server listening to port 443, right? It says, no, I'm not going to do any of that stuff. HTTP 2 or not, it doesn't care. It cares about the TCP transmission, right? So packet number 4 is missing. I'm going to ask for a retransmission. And I'm going to sit here and wait. And then, let's say it got lost again, right? You have send it and wait. And if more packets are lost for congestion reasons or any reason really, the IP packets underneath TCP segments are taking different routes because they have a mind of their own, and they decide to arrive out of order or so you'll have to wait. This blocking time is called head of line blocking, but it's called a TCP head of line blocking in this case. So we solved the head of line blocking at one end, right? But we still have another TCP head of line blocking, because now these streams are just the TCP has no idea of what a stream is or what a channel is. To them, to the TCP stack, this is just a bunch of segments that it needs to arrive in order. it kills you as a developer, as an engineer that says that, oh, but 123 is there. Please process 123. 123 is actually request 1. Nah. And that's one big limitation in HTTP2.
And hey, Hussein from editing. As I was listening to that, I might think that request 1 will be actually delivered to the application because segment 123 has actually arrived in order. What will not be delivered actually, request 2 and request 3, they will definitely be blocked, right? Because, well, request 2 is missing a packet, and request 3, well, you cannot deliver that because there is missing packet. So the TCP's transmission is thinking, well, it's trying to be smart. It's, well, there's a missing packet, I can't just send that, right? So just a clarification here. Back to the video or show.
Right. Now, I gotta be honest with you. I don't know to what extent this is actually a problem. Maybe people who actually built real-time applications on top of gRPC using HTTP2, they feel that, especially, I mean, in a LAN communication, who cares, right? If you're in a LAN, what packets or what segments are being lost, right? Almost none. In a cloud, maybe multi-region, I understand. If you're sending between China and, I don't know, California, some data, well, yeah, some segment will arrive out of order. But to me, I didn't see, I don't know to what extent this is a problem for the gRPC team to take action. Does that make sense? Especially that gRPC is used in a high network bandwidth environment. So I don't think this is a problem, right? But eventually the main problem is HTTP2 is built on top of, essentially the gRPC being built on top of HTTP2. The main problem is the out-of-line order. But this is not even a problem they mention in their proposal, gRPC 3. They just like, we don't really care about this. But I thought I mentioned that. This is a problem. So if you decide to go gRPC, and I know a lot of you in my comment section mentioned that they are using gRPC, take a look at where are your clients and server. Are they tightly tucked in together, or are they far apart and they have the internet in the middle? So that's one thing we need to kind of understand. So the second thing that HTTP2 problem has, well, here's the thing. It's not really a problem. It is a feature that HTTP3 makes it look better. You know the feeling where you're really satisfied with what you have, but when something shiny comes in, it says, "Oh, I want that because it's better than." I just didn't realize that there is something better than what I have. Do you know how they're feeling? I don't know, like you're happy with your computer, right? And it's fast, but you got something really faster than your computer. It's like, wait a second, now I realize my computer is actually slow. You know how I'm feeling? That's exactly how I describe this feature, the next feature that I'm talking about, HTTP2. HTTP2 is built on top of TCP, right? And because it's built on top of TCP, right, there is, and it is an HTTP protocol. So by default, it was listening on port 80, right? That's the default HTTP communication. But guess what? When people actually started doing this thing, right? Listening on HTTP2 port 80 unencrypted. When people did that, the whole protocol started crippling. When they actually hosted on the internet, you might say, why? I say it's HTTP. Yeah, we didn't change anything from the clients, just HTTP. Well, we didn't change that, but we did. Remember, HTTP2 is a break and change from the HTTP protocol. A break and change when it comes to the in-wire transmission. I have to always say that, because otherwise people get mad, right? Yeah, it's not a break and change when you would API, your fetch API, your Axios. A lot of people love Axios for some reason, right? Your Axios didn't change, your HTTP request didn't change. Still, you're sending get post these verbs, but the in-wire is completely different. So middle boxes that routes IP packets, for some reason, especially your NAT, ones, ISP, stuff like that. What those middle boxes do is actually parse the packets and says, oh, this is port 80. That means it must be HTTP. That means here's how HTTP should look like. Beats me. Why are they validating IP packets? Beats me. But some middle boxes do. And when they find out that, oh, port 80 is not really, this doesn't look like HTTP that I know when I was built in 1881. No, router was built in 1881. 1981, whatever that router was built in HTTP, right? Wait a second, isn't HTTP released in the 90s? Yeah, I don't know what I'm saying. But you get my idea, right? So HTTP was really, this is how it looks like. So it was built to be verifying and validating packets of HTTP that looks like this. So when HTTP 2 was sent in the wire, the router freaked out and dropped the packets. So that's why HTTP 2 on unencrypted didn't work. It just didn't work. It stopped working. So people had to, that's why HTTP 2 must be encrypted. If you notice, you have to host your server and serve a TLS and just do a certificate, and people hate when to do all that stuff because they have to learn things that they weren't supposed to learn, which is actually a good thing. You need to know TLS if you're a backend engineer. If you don't know TLS, you should know TLS. You should understand the cost of TLS, the cost of the ciphers, the cost of the signature algorithm. Every single thing you need to understand how you're dealing with this stuff. So this is TLS. I talked about TLS. I'm not gonna go through, but TLS encrypts the stuff, right? Which means there is additional work to establish a connection that we didn't have to. So there's the TCP, which is three-way handshake. Boop, 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 right? Sends an ACK. And then on top of that, you still have to do the client hello, right? Which is the TLS. And if you're 1.2, God knows, God hopes that you don't use TLS 1.1 or 1.0 because these are obsolete. And check your server. TLS 1.2 is actually 4 requests, 2 round trips, right? So there's a TLS hello, there's a client hello, and then server hello, and then they change cipher suite, and then change cipher suite, right? So there's 2 round trips. So 1, 2, 3, 4, 5, 6, 7. 7 things until I can send data. 7 transmission, and any segment that is lost, you gotta retransmit, you gotta wait more. And if Nigel algorithm is enabled, you know, the 40-minute delay thingy, right? The where the TCP client actually waits for more data to arrive from the client to actually send data. That's even adds more delay, right? That's why curl disabled Nigel algorithm. So, you know, TCP no delay. 2016, curl said, the author Daniel Stumberg said, you know what, this TCP no delay is stupid. We don't care. We're not using telnet anymore, right? If I send you something, you better send. Don't wait for this window size thingy to grow. No, just I tell you send, just like the disk. I tell you to flush, right? F-sync, right? That's why databases and operating systems like, hey, operating systems try to be smart. And I tell you to write something to disk, write it. But operating systems, you know, try to be efficient and write to the cache. That's why when you write and you think you wrote but you didn't, durability can suffer as a result. Why am I talking about databases? Again, guys, we're going all over the place. If you like this stuff, like and comment says, Hussein, I like this stuff. Or if you don't like it, say, Hussein, why are you going to talk about database when we're talking about gRPC HTTP3? Stop this nonsense, Hussein. Write in the comment section below. S'il vous plaît. Arigatou gozaimasu. Now, what we're talking about? Yeah. TLS, a lot of delays in TCP with HTTP2. HTTP2 is suffering because it was built on top of TCP. So there is this additional delays, stuff like that. So quick and HTTP3 came back to the action. Actually, HTTP3 was about to be built, right? But the idea was mainly to solve the TCP head of line blocking, this streaming thing. I want the stream. I want, if I receive segment 1, 2, 3, and I want the client, the server, to understand that this belongs to something that is completely irrelevant of the rest of the stuff. So treat it as one unit. Treat these 3 segments as one thing, right? Don't wait for other stuff. Just these are in order. It's all right. Just go your merry way. Okay. So Quick was invented as a result. You might say, Hussein, why didn't they just build HTTP3 on top of UDP, right? And solve this question, right? So why do we need Quick? Well, they thought, it's like, okay, I love this idea of streams and HTTP2, but I don't care about HTTP as a protocol, as a text protocol. I don't care about these verbs. I love the idea of streams. Give me that without the overhead of HTTP, right? And databases love this stuff. No database, very few databases implement HTTP because there's like an overheaders. Who cares? I don't care about headers, HTTP headers. This is stuff that is, I don't care about. I want my protocol to be tight. HTTP2 was pushed down on top of UDP, but they built it on as a layer 4 protocol, so without the HTTP concepts. And this is where Quick came into the picture. I'm going to make another video just talking about Quick. The idea is just to introduce streams on top of UDP. So let's use UDP, which is, there is no guarantee, there is no congestion, there is nothing, there is no retransmission. Packets are sent as packets, right? Let's build our stuff on top of that. Let's build our streams on top of UDP. So if UDP packets 1, 2, 3 arrive, I know that this belongs to a stream. So I'm going to isolate these things. So Quick was born on top of UDP effectively, but it has the features of retransmission. If something is bad, then it will be retransmitted, but only retransmitted if it belongs to the same channel or stream. So now if I sent packet 1, 2, 3, and this belongs to a stream, right? Then and packet 2 was missing, then packet 2 will be resent, right? Ask for a retransmission. But if packet 4, which belongs to stream 2 or channel 2, has nothing to do with it, so I don't have to wait in that situation. So UDP basically was built, and Quick was built, and all that stuff, right? And then when we built that, well, all the work was done for us. Let's build HTTP3 as a thin layer on top of Quick. But before we jump to HTTP3, there's Quick also said, okay, so we do UDP, we're gonna do the handshake. We still, because Quick is still is a connection system, is a connection-based protocol. So we need this idea of a connection. We still need sequences and stuff like that. So if we're gonna build that, then we need to establish a connection. So there is a SYN or SYN-ACK concept. But guess what? They decided that Quick should be encrypted by default. Smart choice. So now Quick is a connection system, right? Is a connection based, but is also encrypted. So now if I ask Quick to establish a Quick connection, I can ask that, and in the same packet I ask to encrypt. So you do TLS 1.3, which is just a single round trip. I didn't talk about that, but you probably know about that, right? TLS 1.3 is just a single round trip instead of TLS 1.2, which is 2, right? So now Quick establishes connection and TLS in a single connection. It's a single round trip. And there is this something called 0 RTT, which is a 0 round trip in Quick that allows you to send encrypted data in the same first handshake with the request to resume an existing session. And that is the most powerful thing. If you can, Cloudflare, I think, started supporting that in their backend, right? So you can do 0 beautiful RTT in a single quick connection. So how fast this thing is. Baba, that's my kid. Sometimes he just goes into her and starts screaming out of nothing. All right, so HTTP3 was built on top of this beautiful, already encrypted, fast connection setup. Man, who doesn't want to use that? So gRPC came into the picture and says, all right, let's propose using that for these reasons, right? So yeah, HTTP3 is built on top of Quick. It's not a thin layer. You might say all the work has been done in Quick. Why do we need HTTP3? HTTP should be really just a call into this existing functionality. But no, there is the compression layer, which is called, I think, QPAC. That's completely different. So they have to rewrite the whole thing into a new protocol. So that kind of changed. That makes HTTP3 a little bit more complex. It's not as easy as just let Quick do all the work, unfortunately. Right? So Quick was also built with the idea of tagging the connection ID in every request. So now you know that there is a connection concept with each packet. It's almost like stateless, but not really stateless. It's just very interesting because every packet has the knowledge about a connection ID. So get this, if you are on your Wi-Fi and you transmit to a 4G, that's absolutely fine. Your IP addresses change, so the UDP packet will have a different IP address, but the content will have a connection ID that the server can use to resume the existing connection that he I don't know why server is they has dropped. So if the connection is dropped, it will be resumed very nicely and smoothly. This is called connection migration or connection transition, right? So this is really a huge sell. So gRPC implementing HTTP3 will get all these beautiful features for free. So there is still work. The proposal is still going. I'm going to have a link below in the show notes. You can click on that and visit. Let me know, guys, what do you think? I think this is a good change. And gRPC might say, if I one final thought before I end the show is, Hussein, you always talk about new shiny things, and a lot of people talk about new shiny thing as they're the ultimate things. Are there problems with HTTP3? Obviously, nobody can say what the problem with HTTP3 unless we start using it, and we barely start using it. Facebook moved to Quick completely on their backend, right? I guess a year ago or so. Now all their backend is Quick, but we don't know. There might be problems that they will. Every solution will have its own problem. This is just the nature of human being. Give me something that a human being built that doesn't have a problem, doesn't exist, right? Anything that we build inherits problems. And HTTP3 is, and HTTP2 for that matter, and HTTP3 is no less. So one problem that we are aware of, which is HTTP3 and Quick, is the CPU usage. You might say, what? Why would Quick take more CPU than TCP, or for that matter, just HTTP, right? Well, remember, guys, the thing I told you about streams and parsing the packets and checking if these packets are in order and checking, oh, these are 3 packets belong to stream 1, these 3 packets belong to stream 2. This is not free. These are things that we never had to do with HTTP 1.1. In HTTP 1.1, the content in the TCP is the content. What you get is what you see. Is that the saying? What you see is what you get? Something like that, right? What you see is what you get. That is it. There is 0 additional processing, minus the frames and the OSI model. You know, just the OSI takes the frames and the packets and the TCP, and that's it. But you don't do additional processing at the content of the TCP segments. You just assemble them and then you go merry way. But now With HTTP2 and Quick, we're doing additional work that we didn't have to do. This is what I want you to think about, guys. Nothing is free in this world. If someone asks you to do something, there is always an intrinsic, purpose behind it. There's always something. There's always something, guys. There's always something. So HTTP3 is a CPU hungry, right? And with gRPC, God knows what gRPC is building on top of that. So gRPC in general, it's already CPU hungry. I know of that because just about the work it's doing, right? It's not just doing HTTP. It's using HTTP as a down, but HTTP is doing its own work. But gRPC is doing more work on top of HTTP. So it gotta be CPU consumption. I didn't see it, but I know it is. It's just logical. You see smoke, there is fire. Okay. So with HTTP3, I have no idea if it will be more or less. Well, it depends, right? It depends on how quick are being implemented and the quick implementation, and it's being improved every single day. Sometimes I attend the live streams of the quick RFC committees and just to watch them. What do they do? They show us like every month. Oh, last month we were using, I don't know, 80% of the CPU. Now we're down to 60%. Or now we're down to, I don't know, same workload, we're down to CPU usage. So it's getting better and better. But yeah, I think it's in general, it's going to become better and better as our machines become more powerful, right? But it always comes to me, I always think about this, my machine, my MacBook, right, is from 2015. It's a 16 gigabyte RAM, quad core. Each core is a single processor, quad core. Each core is 2.4 gigahertz. So I don't know if you're a hardware guy, you might say, oh, this is bad, old, boo. But to me, that's powerful stuff right there. But guess what? OBS is struggling now. I had to add like 300 millisecond delay to sync the audio. Browser Brave is dying. It's like, what is going on in this world? How much power do you need? And that's the slippery slope. If you crave power, you just crave more power. And that's what's happening. It's like, why do iPhones and all these mobile devices need I don't know, 3 gigabyte of RAM, 2 gigabyte of RAM to do these simple things? But apparently these simple things are getting improved. Sometimes you have to ask yourself, is this improvement worth it or not? It's always a cost, right? You want to solve the TCP header problem, right? Head of line blocking. So you need to process, you need to add the idea of streams, HTTP2, HTTP3, that. If you want that, then you need more CPU to run that. So you might say, okay, I'm really happy with HTTP 1.1 on top of TCP. And that's what I think will happen. Eventually, we're going to go into this rabbit hole of us improving, trying to improve something that we don't really need to improve at the end of the day. And we'll end up back to just normal, simple things, right? Remember, when I started this show, what did I say? HTTP, the nature of HTTP was a client sending a lot of requests to the same server. That was the use case, right? And we improved on that use case. So if you don't have that problem, if you're sending one request to your server every, I don't know, few minutes, then you don't need any of this crap, to be honest. That's what I want you to think. I want you to go back to the basic and the fundamentals and think there. Start there and just build it up, right? You might need any of that stuff. And as a result, you're going to consume less memory. You might be, what's the word? You might be just completely out of the left field and say, you know what? I don't need any of that stuff. I'm going to build my own protocol on top of UDP. That's what gamers do. Gamers just like build their own protocol on top of UDP. It's like, I don't need it. It's like, yeah, it's custom. Who cares? Nobody's going to interface with my game, right? I don't need nice API. Hey, is this UDP? I'm just going to send the packet. If it arrives, it arrives. If it didn't, sure, I'm going to solve the problem on the server side, and I'm going to deal with this delay, right? Or going to retransmit in certain situation. Even the idea of feature of retransmission, sometimes you don't need it. That's why video always try to go through the UDP path, right? Video is very hard to go video through the TCP because, like, yeah, if a frame is missing from a video, sure, right? Who cares, right? It's like one glitch, but text and the other one, sometimes you need the transmission. That's why I want you just to have this framework of understanding. Look into your use case and see, why am I doing this? Why am I implementing HTTP3? Why I need gRPC? Why do I need all that stuff? You might have an answer. Your answer might be, oh, because it's hype. If that's your answer, then probably you have to rethink all what you're doing. I'm gonna end it here. I think I've been babbling a lot, but yeah, thank you so much, guys, for checking out this content. Make sure to check out the other content in this channel. I have over 600 videos, by the way. Someone commented like, oh, Hussein, I love your content, but you don't have enough videos. It's like, what? 600 videos is not enough? I mean, I talk a lot. I mean, okay, maybe YouTube is not recommending my content enough, but anyway, check out the content. Check out the show. It's the same thing, is available on Spotify, podcast, Apple Podcasts, all that jazz. Go to HusseinNasser.com/podcast to get the show if you prefer to listen instead of watching on YouTube. But love you so much. If you reached until the end, write a comment like, hey, I reached the end. Because this way I know, it's like some of you are dedicated to watching 30 minutes. I don't even know how long this video is. But yeah, appreciate you guys. Love you so much. I'm gonna see you on the next one. You guys stay awesome all this. Arigatou gozaimasu. Goodbye. Ma'a salama.